Hello guys, welcome to Pepcoding, and today we will gonna solve this question, which is remove before in doubly linked list. So first of all, let's understand the question statement, and some of the functions are already given to us. So let's understand them, and after that we will just go back to our approach. So you are given a partially written doubly linked list class. Okay, you are required to complete the body of remove before function. So we have to complete what? Remove before function. Its size of the list, if size of the list is 0, then return list is empty. First thing is, if size is 0, we have to return list is empty. If index is invalid, then we have to return index is invalid. Okay. If the location which we want to remove is null, then return location is invalid. Okay. If you are required to update head, tail, and size as required, so we also have to update our head, tail, and size of our linked list. Okay. Now let's see its snippet. So we have given what? We have given first function exception, which is list is empty exception. So if list is empty, this function will take care of it. The second thing is index is invalid exception. So if our index is invalid, this function will take care of that. So there are some basic functions, which is add first, add last, add node, add at. So if you come through our made up curriculum, you have already done these questions like remove first node, remove first, right? So today what we will do is, here we have to do remove before. So let's understand our question statement, what our question wants to say to us. Okay, erase it. Let's erase it. Okay, so we have given a linked list, something like 10, and the linked list is doubly. Okay, so 10, and then let's take it 20, then 13, then 15, after that 18, and last let's take 26. Okay, so we have given this kind of linked list. So what we need to do here is, we have given a linked list and we have given a index. So we have given a linked list and index. So for example, if I have given this node as a reference, so we have to remove its previous node. We have to remove this node. We have to remove this node. So after removing the node, our list will look something like this. I like this. 10, 20, sorry, no, 20 is already removed. So this is input, and we have to remove what? Before. Like if this is given to us, we have to remove this index of node of this index. So 10, 13, 15, 18, 26. This is the kind of list remaining after removing the previous node. Okay, so now you understand the question statement. We have given an index and we have to remove a node before that index. Okay, so now let's get to its approach. So there are some of the basic edge cases which we need to focus on. First is what? If list is empty. List is empty. Empty. The question is, if list is empty, how can we remove? Right. So we will discuss about it in a bit. Second case is, if the removed node is head. Node is head. Right. So if remove node is head, so for example, if we have given this as reference and we have to remove this node, right? This is the second case. Then the third case is, so this is head here, right? So if we have given this reference, you have to remove this node. Third option is intermediate stage. Intermediate stage. This is the stage when you have to remove a node. You have to remove a node which come after node, after our head. Like if you need to if you have to given any of these references and you have to remove one of the previous one. So if you have given any references between them, then the way of solving it will be different. Like if I take 18 as reference, so tell me, if the 18 is a reference, what node we need to remove, right? We need to remove 15. How can we remove 15? Now understand this. So before that, let's take care of these cases, which is if the list is empty and if the removed node is head. So first of all, let's take this and let's code this first. If the list is empty, what we need to do? So let's get to our code. This is the function we need to complete. Remove before, right? So first of all, what I will do is we have to complete this function, which is remove before. And so we have given a reference node, right, as an argument. So first of all, we will see if our reference node dot previous is equal to null. If our reference node previous of our reference node is null, then we have system dot out dot print location is invalid. Why? Let me tell you why location is invalid. Just give me a second. Let me you have to return -1 this case, right? So now check it out. Think about it. If we have given this as a reference node, and its previous is what? Null. That means the question is asking us to remove null, but null is not in the list, right? So null is not in our list, and so if we have if the previous of reference node is null, we have to do what? Location is invalid. You have to print location is invalid and you have to return -1. First thing is done. Now for the other cases, let's create another function which will take care of those cases. So return remove before node and reference node. Pass reference node to it. You have to return what? Its data. So let's create this function and then we will talk about it. So public, you have to return what? You have to return node, then name is remove before node reference node, right? So now let's think about it. Well, okay, let's get to our open board and I'll teach you something there. So here let's take our list and let's put it down so that I can show you easily. Let's get down. So this is our list, right? Okay, let's erase some things. Okay, so think about it. First situation is when, think about it, if we have given this as a reference, if this is given as reference, so the thing is we have to remove what? We have to remove this 10. We have to remove this 10, which is already the head of linked list, right? So we have to remove head if the previous, if reference previous is equal to head, right? This is the condition. If reference node previous is equal to head, we have to remove head. So think about it. If we have to remove this head, what we need to do? First thing we need to do is we have to break this bond, these bonds. We have to remove these bonds, right? And then second thing we need to do is we need to move our head to this point, right? This is what we need to do. And by these two cases, we have removed our head. So let's take care of first case foremost, and after that we will understand the intermediate case. If the removable node is head, let's do it. Okay, so first of all, let's make a pointer for previous node, which has to be removed. So reference node dot previous. Then if now we have to check if previous node dot previous is equal to null. If the previous of previous node is null, that means what? That means it is head. If the previous of previous node, so for example, right now head is 20, right? And for example, if this is reference node, so this is previous node, right? So, and this is previous node, then I have to check if previous if the previous of previous node is null. That means previous node is head, right? That's what we write here. That if previous node of previous node is equal to null, that means it's head. Now we have to take care of this head condition. First of all, we do what? Reference node dot previous is equal to null. We break one bond, then we have to break one more bond. Previous node dot next is also equals to null. We have broke two bond. Now comes the third part, which is this dot head. We have to update our head is equal to reference node. Three things are done, right? Now we take care of the second intermediate part, right? If the removable node is none, like it is not null and it is also not our head, then what we need to do is, first of all, let's understand it on our open board. So if remove it, everything. So if we have asked, this is our reference node. So we know that this is our what? Previous node. What we need to do here is we need to remove this node. Exactly right. So there are some things which we need to do. First is I can do what? I can make previous of previous node. This node dot next is equal to reference node. Right. So I break this bond and make it to this bond. And then the second thing I need to do is reference node dot previous is equal to previous dot next. Like so, till now two bonds are already broken. First is this bond, and then second is this bond. Right. Now two things are done. Now the last thing remains is to break this bond and this bond, which is simple. Like what we have to do is previous dot next is equal to null and previous dot previous is equal to null. So after that both of these bonds will be broken, and if we remove these bonds also, what left is this node is already removed. It's done. Our work is done. Let's do it now. Reference node dot previous is equal to previous node dot previous. Now previous node dot previous dot next is equal to reference node. Two things are done. Now we have to break the bond. Previous node dot next is equal to null, and last is previous node dot previous is equal to null. And then the last thing is we have to update the size, right? So this dot size minus minus and then return previous node. Now I think our functions are already done, so let's talk about its time complexity, right? So if we see, we didn't use any loop. No use of loop. First thing is this, we didn't use any kind of loop here, right? And then let's see the second thing is we are accessing only maximum to maximum three nodes. We are accessing just three nodes. One step is this, one step is this, right? So the thing is we are here, the time complexity is O of 1, big O of 1. It's constant. constant, right? So it's done now. Let's submit this. Let's submit this code and see if there is any compilation error. If there is any compilation error, we will check it out. At last, we will just submit it. So let's see if there is any compilation error. Yes, there is. Doubly linked list node cannot be converted to boolean. Okay, at 286. 286. Right. We have to use double equals to here. Again, run it. Accept it. Let's submit this code. Right. So, guys, if you now our code is submitted, correct answer. So, if you understand the explanation, if you understand the logic behind it, please like the video. If you have any query regarding this question, please comment it out and please like our channel. Thank you so much, guys.